This section is rational functions and their graphs. First example talks about points of discontinuity. There's two different types of points of discontinuity. But let's just, in the first example, let's just determine what they are. You look at the denominator to figure out what the points of discontinuity are. The denominator can never equal what? Zero. So what you need to do, if you have a rational function or a rational expression in the numerator and denominator, numerator or denominator, you need to factor it completely. So the first example, we have y equals 1 over x squared plus 2x plus 1. So to get the points of discontinuity, we factor the denominator to x plus 1 and x plus 1. Okay? What would make the denominator equal 0? Negative 1. So that is where I get x equals negative 1 as a point of discontinuity. Okay? Here, in the second example, x, again, we just look at the denominator. X squared plus 1 is not factorable. Agree?
Yes.
If I had x squared minus 1, that would be factorable. But x squared plus 1 is not factorable. So, points of discontinuity, there are none.
Wait, what?
Just look at the denominator. We'll see another example. So that leads us into the different types of points of discontinuity. You either have a vertical asymptote or a pole. So let's look at those two. Can I get rid of this page? Yeah.
When you say it's infactorable, does that mean like you can't, x doesn't solve for anything?
Not a real number.
Not a real number.
Yeah. Alright, in this one, the first example, graph y equals, we're going to graph this. Before you graph it, you have to find all the points of discontinuity. And just by looking at it, you should tell there's a vertical asymptote at x equals 1 and x equals negative 2. Agree? Mm-hmm. Alright, so the first thing you do is draw your vertical asymptotes, which are these two dotted lines. Then all I want you to do is go straight to your calculator. The curves do not have to be exact. We're going to type that straight in. So you go to y equals. Let's clear this. Parentheses. X plus 1. Close. Divided by. Open, open. You have to open two sets here because we're dividing the whole thing by those two in the bottom. What were the two in the bottom?
X minus 1.
X minus 1 and x plus 2. So x minus 1. Close, open. X plus 2. Close, close, and hit graph, and those are the curves you get. This is the newer version calculator. You got to be careful. If you have the older version calculator, the older version calculator does not recognize vertical asymptotes. This one does. So the older version might actually connect these two curves. So yours might be connecting these curves. Are they? But you just got to recognize that those are actually vertical asymptotes. Alright, so all you have to do, again, when you graph this, it doesn't have to be exact. Just know there's a vertical asymptote here and here. And then draw the curves to the best of your ability. It should look something like that. Okay?
Wait, say if you, do we have to worry about graphing the middle one?
What do you mean?
Do we have to graph the middle line?
What line?
The line in the middle.
Yeah.
Do we have to do the ones on the
It should
side?
look, your answer should look just like that. What?
Never
What do you
mind.
mean?
Never mind.
So is it always in a curve like that? The
Not
middle?
always, no. Depends on the function. Okay?
I mean, how do you know it curves like that?
I typed it into the calculator. if you want to get exact, you could zoom into the middle and see what it's doing. Alright, next. Alright, graph y equals x minus 2 over x minus 2 times x minus 1. Now I know I have points of discontinuity at x equals 2 and x equals 1, but x equals 1 is a vertical asymptote. The whole is at x equals 2, and the reason it's a whole is because the numerator and denominator are the same. Okay? If these two divide out, then that's where you get the whole from. Alright? So the first thing you do when you graph it is draw your vertical asymptote at x equals 1. Type this into your calculator, and you should get these two curves. The whole is not going to show up on your calculator. You just got to realize it's there. Alright? So I think it actually comes out to be at 2, 1 if you look at your calculator. Alright? Question on that?
How did you graph the other one? The one at the to the left, to the bottom left?
Did you type it into your calculator?
If you type it in your calculator, you get both of them.
Yeah, you'll get both of those curves.
Okay.
Alright. Next example, just find the vertical asymptotes. That's easy enough, isn't it? First one, just look at the denominator. X equals 2 and x equals 3 are my vertical asymptotes. Next one, you might look at this and say x equals 2 is 1, but it's not because it divides out with the numerator. So there is no vertical asymptote. If I asked for the whole, you would say x equals 2 would be the whole. But no vertical asymptote.
And that would just be like a straight line with the whole. Right?
Correct. Because if you think about it, these two divide out, what are you left with? Y equals x minus 1, which is what type of function?
Linear.
Linear. Forms a line. Okay? Alright, write this down.
That's a lot.
Those are the rules for finding the horizontal asymptote. I abbreviated a lot, so I will read them out to you. To find the horizontal asymptote, there are three different things that could happen. DEG stands for degree. If the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. What is the degree?
The exponent.
What?
The exponent.
The largest exponent of both the numerator and denominator that goes with the variable, right? So you have to think back to what degree is. So let me read this one again. If the degree of the numerator, which is the top, is greater than the degree of the denominator, which is the bottom, then there is no horizontal asymptote. Number two, if the degree of the numerator is less than the degree of the denominator, then you always have a horizontal asymptote at y equals 0. And I think the third one is the easiest one to remember, where the degrees are equal. All you have to do when the degrees are equal is look at the leading coefficients of the numerator and denominator, and that's your horizontal asymptote. Alright, so if I said A was the leading coefficient of the numerator and B is the leading coefficient of the denominator, then y equals A over B is the horizontal asymptote. Does that make sense?
No.
Okay, we'll do some examples and then it will. Okay. I'll come back to it. Alright, here, find the horizontal asymptote of y equals 3x plus 5 over x minus 2. What do you notice about the degrees?
They're the same.
They're both 1. They're equal degrees. So you take the leading coefficient of the top, which is what? 3 and divided by the leading coefficient of the bottom, which is 1, so your horizontal asymptote is just y equals 3. Here, which degree is larger? Denominator, that tells you y equals 0 is a horizontal asymptote, using those 3 rules. Very simple, if you remember those rules. Got that one? And graph here, y equals x plus 2 over x plus 3 and x minus 4. First thing you always find is the points of discontinuity, which include the vertical asymptotes and the horizontal asymptote. Alright, so the vertical asymptotes, you should be able to look at it and tell are x equals -3 and x equals positive 4. What is the degree of the numerator? 1. What about denominator? 2. Everybody see that? Because if I multiply this out, what's x times x? X squared. So the degree of the bottom is 2. So that tells you you have a horizontal asymptote at y equals 0, since the bottom degree was greater than the top degree. Okay, so draw your asymptotes, vertical, label. Since your horizontal falls on the x-axis, just label it as y equals 0. If it was anywhere else, you would have to draw a dotted line. Alright? And then just type this straight into the calculator and copy the curves as best possible. And that's it. Now if you want to get exact on the points, you can always do a table of values. Alright? Question?